Hello guys, and welcome to part 1 of how to make your own quadcopter series. Now in part 1 we are going to learn how the quadcopter works. Now first of all, why do you need to learn how the quadcopter works? Why can't I just go buy the parts, put them together and voila, quadcopter? Well, if there are any problems with the quadcopter, if you know how it works, you know how to fix it. Now if you have not learned the basics of the quadcopter, and if even there is a small minute mistake, you would not know what's going on and would pull your hair apart because it is very frustrating. Now before we dig into the parts or how to build it, let's go and see how it works. Now this is going to be a fairly longer video because I'm going to explain you everything on how this quadcopter works. Now first of all, this is the quadcopter. I'm going to show you how it works. Now the first thing about aeronautics is that every flying object has 4 forces acting on it. One is the lift force. The lift force is the force that keeps your quadcopter in the air. So the lift force is obviously acting on the ground. So that's your lift force. The counteracting force to that is the weight force. Now the weight is obviously trying to pull your quadcopter down. So now the weight includes the Earth's gravity or anything that's trying to push the quadcopter down, including atmospheric pressure. And then the next thing is going to be your thrust. Now the thrust is, according to planes or according to anything out there, is going to be the force that's required to move any flying object forward. Now drag is going to be the thing that's pushing back your quad, that's going to be mostly air or anything else that's not allowing your quad to go forward. That's called drag. Now, for any quadcopter to fly, the thrust should be greater than the drag. So the thrust, drag. Thrust should always be greater than the drag so that you can move forward. Again, lift should be greater than weight. If lift is not greater than weight, the quadcopter is obviously not going to take off. Now this is not only to the quadcopter, even the airplane has the same, helicopter, anything that's flying out there, even a paper plane has to counteract with these 4 forces to achieve flying. Now every single time thrust and lift should be more greater than drag and weight. If they are not, the quadcopter is not going to fly. Well, there are a few exceptional cases when you are trying to hover, the thrust may not be there. But always, every single case, every single thing, lift should always be greater than weight. If it's not, your quadcopter is not going to fly. Now the next thing is, the good thing about these quadcopters, airplanes have wings, but these quadcopters have these special airfoil shaped propellers. Now what these do, these are meant to direct air towards the ground. Same thing like an airplane, but with a bit more twist in them. So if you can see these, they have a shape that's like this. It's a pushing down shape. And I don't know if you guys can see it, but the shape is like that. So basically, what this does is, it chops to the air and gets all the air down. So when you have this on the motor and it spins at very high speeds, it pushes a lot of air down, which makes your quadcopter lift off the ground. Now the next thing that is quite shocking but is quite real is when you lift these quadcopters, not all the 4 motors are running at the same direction. So now this is a small diagram. If you guys can see this, it shows that motors 1 and 3 are moving in the clockwise direction, and motors 3 and 4 are running in the counterclockwise direction. So now why is this? Because as Newton's 3rd law of motion says that every action has an equal and opposite reaction. When all the motors are spinning at one side, there's an equal and opposite reaction for the quad to be spinning at the other side. Now the best way to explain this is with the helicopter. Now if you have ever seen a helicopter, they have one motor here and the other motor that's spinning parallelly over here. So what does this motor do is, this motor doesn't allow the helicopter to spin. Helicopters without this motor usually tend to spin a lot at the yaw. The same thing happens with the quadcopter. Newton's 3rd law of motion, if all the motors are spinning in the clockwise direction, Newton's 3rd law of motion says that every action has an equal and opposite reaction, so I'm also going to give some force that's acting on the other way. So basically instead the quad would take off like this. It should take off like this, but the quad takes off like this. So that's not what should happen, right? So to counteract that, two motors are made to put air downward in the clockwise direction and the other two are counterclockwise direction. Now the propeller that I have here is a counterclockwise propeller, and the clockwise propeller would be exactly the opposite of this. So this is the main thing about the quad. If you don't get your propellers or the motors running at the proper direction they should, it's going to be a big headache for you. Now it's your wish to check if this should be counterclockwise and these two clockwise and these two are counterclockwise. That's your wish. But it's always recommended that the first motor is always the first motor from your left hand side. This is second and third and fourth. So it goes like this. So the first motor should always be clockwise, not counter. First and three should always be clockwise. The other two can be counterclockwise. Now this is usually recommended, but switching it does not actually make a difference because I have switched it and I didn't see any performance dip at all. So now that's how the quadcopter takes off. Basically these two motors spin clockwise and these two counterclockwise, and the quadcopter takes off. That's how it hovers as well. Now the next thing is, how does the quadcopter move front? Now this does not have any motor like the plane that's actually pushing back on it, if you can see. It does not have a separate motor or engine that's pushing air back. Then how does it move front? Well, the quadcopter moves by tilt. So now let's just say that, think this is the force that's applied by the quadcopter, okay? Now this is going to be the force that's going to be applied by the quadcopter on a downward angle. That's going to be the lift is going to apply this force and the quadcopter is going to be flying stably. Now when it wants to move front, what does it need to do? Well, it needs to apply more force towards the back. So the quadcopter basically just tilts itself a bit so that there's more force acting on the back than there is on the front. Now this will also tilt, and the force that's acting is not straight, it's in a slant way. So that means there's more force at the back and the quadcopter can move front. So unlike planes, quadcopters can move front, back as well. Same technology, just make these two motors spin a bit slower and these two a bit faster for the quadcopter to tilt itself and make a bit of the force acting slantingly so that it can still keep itself upset and also that it can push itself front. Now this is a diagram of this. Now you can see motors 3 and 4 are having a bigger wings. Bigger wings means more thrust. 1 and 2 on the other hand are smaller because they need to be going a little bit slower than motors 3 and 4. Now the speed can also be varied like this, is that a more angle means more speed. Now obviously if I keep the quadcopter on this angle, then the angle of the force acting on it will also change and there will be a greater force that's acting on the back. Whereas if I keep the motor on just a slight tilt angle, the angle will be very small and the speed will also be small. So that's how the quadcopter moves front. If it wants to move back, same thing it needs to do. It needs to get these two slower, these two faster. It's going to move back. So that's basically how the quadcopter does pitch and yaw. Okay, now the next thing is going to be roll. So now what's roll? This is roll. Now the roll means that moving left or moving right. So this is done by the quadcopter by switching the same thing but adding 2 faster over here and 2 slow over here. So this is the diagram. Now if you can see, these two are faster and these two are slower. So what that does is, let's just say I want to move that side. Same thing. This is going to be the force that's acting on the quadcopter as it's flying. But now, when I increase the speed over here and decrease it over here, again the angle is going to change. And because there is more force acting on towards this side, the quadcopter is going to move. Same thing, opposite way, same work. Now the next thing is, you might have seen quadcopters or helicopters rotating on their own axis. Now this is hard to achieve as the quadcopter should continuously hover and rotate on its own axis. So, remember when we told you about the Newton's third law that every action has an equal and opposite reaction, and if it's not counteracted with enough force, then your quadcopter is going to start spinning? Well, now we are actually going to take advantage of that. How? Like this. Now if you can see here, motors 1 and 3 are moving faster than motors 2 and 4. So what's that doing is, when motors 1 and 3 run faster, then basically Newton's third law of motion kicks in and it's going to turn. Same thing happens when you want to turn it the other way. Motors 2 and 4 will start spinning faster, and motors 1 and 3 are going to slow down, and again Newton's third law is going to start in and is going to tilt it again. Now if you want the speed of the tilting again depends on how fast are you going to change this. So that's basically how the quadcopter works in a beginner level. If you didn't understand this, please go and check on my Instructable, where I also explain this with all these diagrams given over there. So thank you guys, that's it for this video. I hope you have understand how the quadcopter rotates, moves forward and moves backwards. Now in the next video we are going to talk about the parts, and also we are going to talk about how the parts talk to each other and how will it work. Thank you guys. See you next time.